Hello, I'm going to show you how to visualize bubble sort algorithm using Python inside Houdini. If you are interested in visualization for the algorithm, you can check another video of created by Junichiro. It's also for bubble sort algorithm, but he did not use Python, he used Vex. For the same algorithm, you can also check coding train. It's not 3D visualization, but it's the same idea, like how to visualize a bubble sort algorithm using Java by using B5 library. Okay, but my version will be purely in Python and inside Houdini. So this is the code that we are going to work in today. Let me run this code and show you the result. This code will generate 60 random value. Okay, and it will show animation how the algorithm work to sort this value. So here the item, it's range from I think from 0 to 100. Yeah, you can specify what it's random, and we can also have negative and it will sort that even. You can also adjust the speed of sorting. Right now just randomly choose value. Right now it's sorting. It's called bubble because if you can see the highest value go to the top, the next iteration the next top, third, this is the fourth. In our example we'll have like 2 loop. I it's mean the whole set, j it's mean individual. Each I will end up with the highest one on the top. That's why it's like the highest value bubble to the top. And I'll show you the idea how this is working out. The idea is like you compare two value. If it's greater than, let's say this one is greater than this one, so swap. The idea is like keep swap. This will end up with like the highest value is on the top. And you can visualize the same sorting but using different idea, like you can use color. So let me show you the color, how to sort using color. Okay, let me run the color version. Again here the highest value is the red, blue is the lowest, so red should be on the top and blue on the bottom. And it will compare if the bottom is red and the top is blue, it's swap. Keep swap, and you can see how it's stack every. And the idea of the algorithm, we don't, once we have let's say 8 iteration, 10 iteration, we don't have to try to sort this because it's already sorted. So we can reduce the time by excluding whatever sorted here, because in every iteration we are 100% sure that the maximum value is on the correct position, and here it's sorted. Okay, let me show you. Last one is using angle, and here's the angle version. You see it's random angle from -90 to +90. So we'll see how it will be sorted. And this is almost 90, so that's less than 90. Keep sorting from 90 to -90, which is here the speed is 0.1 of the second each iteration, and we have 60 item, so this loop will run at maximum 60 multiplied by 60. In order to get this sorted. So this algorithm is not very efficient, but it will do the work, and it's fun to see how it's do the sorting. So here we see we have like the maximum angle, and here we have the lowest angle. Okay, now let's go back to the coding, and let me put Python. Let me Alt E just to get bigger. Right now we don't need this one. Let's say we have this list, and let's randomly pick some item 5, 1, and 9, and 3. That's enough. Okay, so let me show you how this algorithm works. Okay, first the algorithm we need to sort this one, okay, from lowest to the maximum. So we need the highest value to be on the top. So the algorithm starts by the first one and compare it to the next one. Okay, so 5 is greater than 1, so we need here to swap between them. So the next run will be we have a swap. This one become 5. Okay, now next step is to compare this one by this one. 5 is not greater than 9, so do not swap. Right here we don't need to do anything. So next step is we'll compare 9 with 3. 9 is greater than 3, so swap 9. So this will be 3, and this one will be 9. Okay, so this is the first loop. End up with one item in the correct position, but we don't know about this thing, so we need to sort this one. So in the loop we'll have like minus whatever I is. Okay, so next one right now we'll go back again, we'll do again right now, but we don't need to compare these because we are 100% sure that this is the maximum one because it's bubbled up to the top from the first iteration. So right now we have like this one, so we compare 1 and 5. 1 is not greater than 5, so no swap here. Okay, and then 5 is greater than 3. Here we need to swap. Okay, and then here 5 is, we say we do not compare that because it's 100%, it's in the correct order. So in the second iteration we have the 5 in the correct place, but the algorithm how we write it, it will also compare again this and this, and it will find 1 is not greater than 3, so no swap, and it will exit and will give us this results sorted. Okay, so let's say we still have here 10. Okay, the same idea, like once we run the iteration, 10 will be, forget about this one, let's say we have this one, the first iteration 10 will be there because it will keep swap 10 10 10 10 10 till it will be at the end. And this is the algorithm. So let me write that code. Right now we will not do visualization, it's just the algorithm. Bubble sort, it will take a list, and let's get the number of item. This will be, in this case, is 4. Okay, now we need to have 2 for loop for I in range of n minus 1. Okay, so if you print this one, yeah, we need to call this function. Just let me. from 0 to 3 because we don't need to use this one, because we are comparing this one with the next one, I plus 1. So if we use this value, there is nothing next to it, so we cannot compare. Okay, so but right now we need to also to write the next loop here for j in range of, let's say this one, from 0 to n minus I. So I mean, like, let's say I is 3, which means we have a 3 on the top sorted, so we don't need to run the algorithm again. So this will save us sometimes. And minus 1, this is by default because we have another one. So, and here we have the compare between if list of j, okay, greater than list of j plus 1. We need all like always this plus 1 because minus 1, so we will find this item, will not get an error. Okay, so we'll compare this one. In this case, the first iteration will have 5 is 5 greater than 1, which is j plus 1. If it's true, which means swap. Okay, swap, we will write this function right now. Swap the list between j and j plus 1. Okay, so we need to swap between these two. Okay, and at the end return list. This is the algorithm. Okay, we still have to write swap function. Okay, but this is the idea. Okay, this swap will keep doing what I show, like swapping between item, and the result will be everything is sorted. So let me write swap function. Swap, it will take a list and A and B. Okay, now to do that we need first to store the value of A. Let's, for example, list A. Okay, now list A equal list B, then list B equal, no, you cannot do like this will not work. The reason why we have this temp value, because here, forget about this temp. Okay, just let's say if we need to swap between them, here we change the value of A to B, and right now we need to change the value of B to A, but we already changed this one, so this will be B equal the same value. So basically we lost the original value of A, so this 5 will be gone, and we'll have like 1. So the reason why we have here temp, just to store that, and here we completely forget about the A value, but we store it here, so we can assign it back to the B. Yep, and right now it should work. Okay, it's 1359. We started from 5193, so it's sorted. Let's do some other thing. For example, -5 plus. Okay, and let's put here some. Okay, see, it's sorted from -5 to, and look fast, but there is many sorting algorithm which is faster than this one, but maybe in future I will visualize a lot of them. But for now, let's do the visualization thing. So right now, after we have this sorted out, for animation, the idea here, if we use this like node for animation. In Houdini, this node should be to get the result in the canvas of Houdini. This should be cooked full, like once the code is finished, we get the result, so we will not be able to see animation. That's why I decided to do it. Go to the Windows and Python source editors. Okay, here we have Python source editors, but let me open new Python, so we'll have like fresh clean copy of. Okay, yeah, okay, go to the Windows. First let's create geo, and inside here we'll have all the animation. Go to the Windows and Python source editors. Okay, first we need to import time, because we need to have timer. In this tutorial we don't have like keyframing. You can add keyframe in Python, but for now we need to see what's going on inside the for loop, like just to slow it down. So by using time we can, okay, just show me what is going on inside the first iteration next. So this will give us animation. We also need to import random. This will give us a random number. And okay, now we need to have to generate, let's see, run okay. Let's first get random items equal random.uniform. Let's start from, let's say, -10. Okay, for in range of, let's say we need just for testing, let's say 20 value. Okay, yeah, -10 up to 10, and we will have 20 item. Okay, you can change it whatever you want, but for this case we'll use 20. So let me show you what is this value will be. It will be a range from -10 to 10, float value, 20 item. So let me get Python shell and save. Okay, now how we call this function is, this is a session. You see here session module, so you go to HOU session, and then it will give you your function, run bubble sort, and you run it. And here the random item that we generated. Okay, now on Python you can do this sort function. All you need to do to sort this thing is just write sort. It will get sorted item for free. You don't have to write anything. Of course, the Python, they use more complex algorithm for sorting than the one we use right now. But the idea is to see how different sorting algorithm do the sorting, or the idea behind how the sorting is working. There's many algorithms that use for sorting, and bubble sort is one of them. It's not the time efficient one, but it's fun to see how it's working. maybe in future I will do other visualization for some algorithm like sorting, graph algorithm, and many more, depend on the time. So right now we have this item. Let us get this node, geo node. You can see here the same like geo and the name of the node that we want. Okay, this is exactly the same here. Okay, basically in this geo node you can do everything you can do here, you can do it inside Python. Whatever you do in the mouse and keyboard on real like a real way to use Houdini, it can be done on Python. So you can create node, you can delete, you can color, you can align, you can connect them, whatever you want. So now here we have these items, and we need to create boxes based on this item. So we'll have like 20 boxes, and each box will have the length of this item. So in order to create that, we need to loop over this number of items. So we'll have like 20 boxes. I is the index and the item is the value. So let me change this name into like values and yeah, index. Now B is for we'll store the box. Geo node, that's whatever is we have here, and it's the same thing, like you create box and you can from here say create node, and you give the name of the node you want to create, which is box, and then we have an option to add name for that. The name will have like box plus whatever I we have, whatever index we have. Okay, if we run this code, basically we should get 20 bucks. Okay, so let's run this. Oh, I is not, oh okay, because we changed it to index. So let's do this index. Oh, let's do just I and we are fine to go. Okay, we should get 20 bucks. Here we are, 20 boxes. Okay. Right now we need to merge these boxes. Here how we do it inside Houdini. Okay, we can do the same in Python. Let me show you how. For merge we don't need to have 20 merge, we only need one. So let's create merge on the top. The same idea, geonode, create node, merge, and we don't have to use the name, just let Python give us the name that he will choose. Now we need to connect these B's. We have B equal, we need to connect these boxes to the merge. To do that we have a function called set input. Okay, this function takes 3 arguments. The first one is where is the location. Okay, the second one is what is the P in our case, or what is the node that you want to connect to this merge. So we need to have this box connected to this, and here's the location. We need it to be basically whatever index we have, in this case I. Let me show you here how the idea of indices. Here we have 4 indices, so 0, 1, 2, 3. So if you want to connect to this, the second or third, all you have to do is here. So you can connect whatever you want. On merge we have infinite amount, so you can connect whatever you want, but still there is some order for that. But at the end it will merge all of them together. So let's say we have so we have sphere 1 and sphere 2, and let's connect sphere 1, sphere 2 first. So we'll have sphere 2 is on the index 0, sphere 1 is the index 1. So but the end result is the same. Okay, so this is just to give you an idea about this input thing, just to know what we are doing here. And the third one is I think the third one is for the output, if you want to connect something, but right now we don't need to connect anything to the merge. We like it as is. And if we run this code, we should get 20 boxes all attached to the merge. See how it's fast? Oh, all it is attached and on the same I order, so that will look nice. Now we have all the boxes on the same size. Okay, so right now we need to change the length of the boxes based on the value we have. Okay, so also we need to store each boxes on the array so we can keep track of them. So we append the p, so we don't lose we keep tracking this whatever number we have of the boxes, so we can refer to them when we use swapping. So we can get these boxes and swap between them. Okay, now we need to have a length to set the length of these boxes. It will be a range from -10 to 10 in our case. All we need to do is change the size, depend on the value. So if we increase the size, we'll get longer or shorter. Okay, and if you see here the size, there is like parameter for size X, size Y, size Z. So we'll adjust that in the code. Yeah, you can do whatever you want, all kind of adjustment randomly, because we have random value. We have 20 boxes, we can do whatever we want, like randomly. We can have like completely 20 random boxes, different orientation, different length, different thickness, different location. Also we need to change the location. If you see the center on Y, because we don't need all boxes to be on the same like location, we need each box to be level higher than the other, just to see them. Okay, so first we will change the size on X. Dot set, and we'll have, you cannot do equal, you have to use this function to change this value. What we'll need here is to use the value. Okay, so this will be -10 to 10, any value. So we'll have random size boxes, Next step is changing the center. For center, they have different names. Not center X, center Y. It has T from, I think, from transformation, something like translation. Yeah, this T, TX, TY, TZ. What we are interested in, TY. So just to move each box some amount, okay, based on the I. Let's say I0, keep the box on the floor, I2, and so on. I. So each box will be like on the top. It will be stacked basically, because we have 20 stacked box. So let me run this code and see the result. That's, here we have the same boxes and randomly, and the blue one is a negative one because normal is flipped, but for now it's okay, just fine. Here we need to add the spaces between each of them, so it's not like completely stacked together. So we'll use the same current position plus whatever spacing we decided, and we multiply this with I. This will give us 0.5 space between each boxes. You see, now we have spacing. Next step is to have make all the boxes aligned to either left or right. Right now it's all in the center. Okay, so what we need is to change the center, so each box will choose like either right or left, depending if it's positive go to the right, if negative go to the left. So it's all stacked on the center line. It's not like, you will see what I mean. Yes. Usually in Houdini, if you want to put some box on the ground or something, we take the size and divide it by 2. See, it's go to the 0. So if we did this for all, we'll have all of them nicely stacked on either on the left side or the right. The same, let's say for this negative one, if we did the same copy relative, divided by 2, and you see it's stacked on this left side. So let me show you here. It will be clear. Like if you see the box is it's in the center, like basically. So part of it is under the floor. So the trick to make it on the top of floor is to get whatever height we have and divide it by 2. Boom, it's on floor. So the same idea, the same thing. If you do it into other axis, it will use the other axis to starting point. Okay, it does. So right now it's started from here. If you did also on the Z axis, it will have the box like pivoted into the all positive axis 3D space. So let's do that inside Python. Tx dot set value, not this should be value, not item. The reason why I'm recording the audio, because somehow I did not get the audio from the first time, so that's why I'm doing voiceover again. Okay, that should do it. Now we have it. Okay, now we are ready for writing sorting algorithm. It will be the same one we created earlier. The only difference is we use the boxes array inside the swap to start moving these boxes. Okay, now let's create the actual algorithm. It will take list and boxes. Previously we don't need to use boxes, but right now we will have them, so we can use them in the swap. And this changes list into item, because keep everything the same. Right now it's list. Now let's get the number of item we have. So changes to the item, so just to keep everything organized. And now we start the two for loops. For I in range of n minus 1, for j in range of 0 to n minus I minus 1. Now do the compare if item, not list. Swap if the first item greater than the item. Swap item j plus 1 and give the boxes, just to swap the boxes also. So we'll do the same what we did previously, plus swapping the boxes and moving them inside Houdini, and this will return us the list. This is will get printed value. So let's run this function inside the main function, and bubble sort, we give it we'll give it the items and boxes, and let's print this out. Let's write swap function. Swap will take A, B and boxes. Now the same idea, we need to use the temp. List A equal list B. Sorry, items. Okay. Equal items B, item B equal temp. That's how to swap to value. There is more than one way to swap this thing. There is, like, you can do it in Python one line to swap them. Maybe I'll show it later, but for now that's what we get the same error. Okay, now we have all the items displayed, and we don't have any effect right now on them because we did not do swapping for the actual element. We have the correct algorithm, however. If you see down, we have like all listed, all sorted list, but right now we need to change swap between the size of box 1 and box 2 and change the location. Sorry, we need to change the location. Let's say this box, this location, and this location is 3. We need to change. The only way to swap is make box 1 equal whatever box 2 have, and make box 2 equal whatever box 1 have. So that's why we'll move one box top level and the one is below, so that's swapping. That's what it is. So let's do that. Now the same idea, we have the boxes, and we have box A and box B. So let's start with box A. Get the position of the box A. Okay, this is ty eval set let you set number for the parameters. Eval give you whatever result we have right now. So in this case, box A, let's say, will be 1.5, box 2 will be 1. Or box 2 will be 3. So swap this value. So let's get also box B and just change this one to B. And right now we have this value, and we need to set this into actual boxes inside Houdini. So we'll do the same. Instead of val, we use set. So boxes A dot param ty dot set box B value. The same for box B. We'll give it box A. Just because we did not swap the boxes. So let me run that. Okay, now we cannot see exactly what's going on because we don't use time. If you look on the top, we have a time, importing time. Yeah, you see it's sorted in the text, but it's not as a visualization because we don't sort the boxes. And we also need to slow down the Python because for loop is very fast. CPU process very fast, so we could not see that. That's why we have time function. So we'll use it after j, loop on j. So here, time dot sleep. Let's use 0.1. Yeah, this will slow down so we can see animation on swapping. But right now we'll see swapping is chaotic because we don't change the order of we don't swap the boxes in the array. It's not on the Houdini. So let me save and run again. We should see animation right now. Right now, just initiate. This is the swapping thing, but you can see it's not swapping anything. Just I don't know. But like 2 line will fix, 3 line will fix this issue. 1 line for temp, 1 for assign box A, 1 for assign box B. So the idea is like right now the result does not match the boxes. Okay, now let's do the same idea. Temp box equal boxes of A, and boxes of A equal boxes of B, and boxes of B equal temp box. We're almost done. We're done. Actually, there's nothing to do right now. Just save and run, and you'll see the sorting in action. Right now we have like 3 swap. 1 for the actual operation, 1 for the boxes, 1 for animation. And let's go. Save. And run. Let me delete and run. You see how it's bubbling up. Yeah, the highest value go up. So here you have it. Let me do some changing, like increase the number of 100, and let's make it faster, 0.1, and let's keep this the same. That's fine. Okay, now the sorting is begun. So see, this is fixed I, and the fixed one, second one in the correct position, fourth, fifth. Keep doing that, swapping till the end. And you can do many things, like it's not you can adjust, you can do as I showed you earlier, like you can use colors, you can use angle, you can use all kind of the sorting thing. And this animation is not keyframe animation, just Python, and we slow down whatever Python is doing, and just to able to see it. But if you run this without time, you'll get the result just very fast. You'll not be able to see this kind of movement. You can in Python set keyframe. Instead of doing this thing, you can add rotation. You can make them like flip in a circular fashion. You can make them one go up, go down, go left. You can do all kind of things. Like just you can also add color depend on the status. Let's say right now we are comparing box A and B, and they are equal. Let's move them so you can have like a green, red colors, and if they equal blue, you can do all kind of things. And we almost done sorting. Maybe next I will do some other sorting stuff. And we almost done sorting. This algorithm is take like 10,000 iteration, because we have 100 item, so n by n, so it will be like 10,000.